Hello guys, and welcome once more to this new video in our YouTube channel. So into this video we are going to show that the limit as x tends to 0 of 1 minus cos x divided by x squared is actually equal to a half actually. So the first thing that we are going to try to do is first of all try to substitute the value of x into this expression and see what we can get from there actually. So if we do that, we are going to obtain what? If we first of all try to include everywhere you see x with 0, we're going to have 1 minus cos 0, okay, and cos 0 is actually 1. So in the numerator we are going to have 1 minus 1, which gives us 0, and in the denominator we are going to have 0 actually, from which we are going to obtain actually 0 divided by 0, and actually with actually an undeterminate form actually. Yes, so we cannot conclude from here actually. What then can we do in order for us to remove this undetermination and actually get the required proof, that is the limit at x equals to 0 of 1 minus cos x divided by x squared is actually equal to a half actually. Yes, so if you look it more closer, you can still write this expression as what? As the limit as x tends to 0 of 1 minus cos x divided by x squared, that if you multiply top and bottom with 1 plus cos x, you're going to obtain this expression. You can clearly see that the numerator actually is going to give us difference of 2 squares actually, okay, from which we can write it as what? The limit as x tends to 0 of, as I said, that the numerator corresponds actually to a difference of 2 squares. That is 1 squared minus cos squared x, but 1 squared still gives us 1 actually, and the denominator will simply remain as x squared times 1 plus cos x actually. We know that from trigonometric identity that cos squared x plus sin squared x actually gives us 1. So it therefore implies 1 minus cos squared x actually give us sin squared x actually. So from which we are going to obtain therefore the limit as x tends to 0 of sin squared x, okay, then divided by x squared times 1 plus cos x. If we bring sin squared x and x squared together, we are going to obtain the limit as x tends to 0 of sin x divided by x all squared, then times 1 divided by 1 plus cos x actually. Yes, so we know that what, as x tends to 0, of course sin x divided by x tends to 1 actually. This is a very important fundamental limit actually, okay, from which I will simply leave the link to the video, okay, where I actually prove this into the description, so they can go and watch it there actually, okay. But you have to take note that actually this is actually a very important fundamental limit, that the limit at x tends to 0, okay, as of sin x divided by x actually give us 1. That is, you can see write it as x tends to 0, sin x divided by x actually turns to 1 actually, okay. Yes, and as well as x tends to 0, what happens to this part, that is 1 divided by 1 plus cos x? It turns to a half. Why? Because as x tends to 0, it implies we are going to have 1 divided by 1 plus cos 0. That is everywhere we see x with 0 actually, which we are going to obtain what? We are going to obtain 1 divided by 1 plus 1 actually gives actually a half actually. Yes, from which we can therefore conclude that the limit as x tends to 0 of sin x divided by x, okay, all squared times 1 divided by 1 plus cos x, okay, to be equals to 1 squared, because as we all as I said, that is this limit actually gives us 1 as x tends to 0 of course, okay. 1 squared times a half, okay, and 1 squared actually gives us 1, then 1 times a half simply gives us actually a half actually. And this is actually we can therefore conclude that the limit as x tends to 0 of 1 minus cos x divided by x squared is actually equal to a half actually, with actually what was required for us actually to prove actually. Okay, thank you very much for watching this video. Okay, in a subsequent video we are going to see an example in which actually we apply this fundamental limit, because actually it's a very important fundamental limit actually. So in a subsequent video we are going to we are going to look at an example actually where we can apply this fundamental limit. Thank you very much, and see you then for a very next interesting video. Bye bye.